In order to prepare for finding those more accurate answers, you need to know what a z-score is. The standard score, or z-score, just represents the number of standard deviations a value x lies from the mean. And to find the z-score for a value, you just use the simple formula below. Whatever value you're interested in, you subtract it from the mean, divide by the standard deviation, and here's that formula in symbols. When we get a z-score, that number is literally a location of what standard deviation you're closest to. Are you one standard deviation above average? Are you two standard deviations above average? And what you'll see in this picture is anybody who falls within -2, so 2 standard deviations below the mean to 2 standard deviations above the mean, those are considered ordinary or usual values. If you are beyond 2 standard deviations above or below the mean, those are much more unusual. That's where the curve tapers off. So now we can actually use a z-score to locate the position of a particular piece of data within the data set. So in this example, the mean speed of vehicles along a stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speeds of 3 cars traveling along this stretch of a highway as 62 miles an hour, 47 miles an hour, and 56 miles an hour. Find the z-score that corresponds to each speed. And we do need to assume that the distribution of speeds is approximately bell-shaped, which seems reasonable. Most people will do about the average. You'll have a few who are extremely high above and a few who are extremely slow. Were any of these cars traveling unusually fast or slow? So the first thing we're going to need to do for each of these 3 speeds is determine the z-score. So one notation that we do sometimes use is put the value that we're calculating the z-score for as a little subscript at the end. So I'm indicating I'm finding the z-score for 62. The formula says we take the value that we're finding the z-score for minus the mean divided by the standard deviation. I was told my value is 62. The mean is this one right here, 56 miles per hour. And my standard deviation was here. So that's 4 miles per hour. 62 take away 56 is 6 over 4, which gives me a z-score of 3 over 2, which is the same as 1.5. So what I know immediately is because my z-score is positive, this speed, 62 miles an hour, was above average. Okay, any z-score that's positive was above the mean. Any z-score that's negative is below the mean. And I know specifically, because it worked out to be 1.5, that it was located right here, which is near the upper boundary for an ordinary value. I would now repeat and find the z-score for 47 and the z-score for 56. I've shown you my substitution and then simplifying and the z-score I got for the remaining 2 values. 47, that speed corresponded to a z-score of -2.25. So this person was traveling at a below average speed. And when we look where -2.25 is on this number line, -2 is here, and it would be just to the left of that. So this one is an unusual speed, and it's unusually slow because it's below average. So this one was unusually slow. And then for 56, we got a z-score of 0. That's because the mean is always found in the middle. So the mean will always have a z-score of 0. And that literally tells you that this person was driving the average speed. So if I had to describe each of these situations, I would say 62 miles an hour, this person was going faster than average. 47 miles an hour is unusually slow. And 56 means they were traveling the average speed. You can see how z-score gives you important information as to where that piece of data fits into the data set as a whole. The standard normal distribution is a normal distribution with a mean of 0 always and a standard deviation of 1 always. And the total area under its normal curve is going to be 1, and that's going to be an important fact. So the next skill we're going to work on is to be able to calculate the cumulative area that corresponds to a particular z-score on this standard normal distribution. Okay, and again, the only difference between a standard normal distribution and a just plain old normal distribution is the standard one always has the mean at 0 and a standard deviation of 1. So when we're talking about the cumulative area, it's the total area from the left edge of the distribution all the way up to a given z-score. The cumulative area is close to 0, z-score is close to negative 3.49, and then it's close to 1 for z-scores close to 3.49. So let's look at that on here. So what we were just saying is we were talking about a z-score of negative 3.49. And you can see that there's hardly any area out here. It would be a very, very small shaded area here. So that's close to 0 in terms of the cumulative area, because remember, cumulative area is going to start from the left edge of the graph and measure the blue shaded area up to that z-score. Now, if we wanted to do the cumulative area for 3.49 positive, that's all the way out here. So I would start from this left edge and I would find the area of the blue shaded region all the way up to here. And of course, that's going to be close to 1 because the area of the whole thing all the way out to the left to all the way out to the right should total 1. Now, how do we know, for instance, if my z-score is 2, how do I know how much of the area is here? Well, there's something called a standard normal table, which is a tool to find the cumulative area that corresponds to a z-score. The standard normal table is a fold-out page at the very back of your textbook. But if for some reason it's not there, I did also upload a PDF of the table of values to this week's module. This is the standard normal table. This is what it looks like. Whole lot of numbers. And what you're going to notice is it's showing you here that this table gives you the cumulative area from the left edge of the graph to whatever z-score you are looking up. You'll notice you have z here, and then you have numbers down and numbers across. Then you'll also get a similar table for positive values of z. Now, since z is positive, it would be larger than average. So that's why in this picture, you're going to see z all the way out here. These numbers represent the cumulative area starting at the left edge of the curve all the way up to here. So adding up all of this area. I'll show you in this example how to use this table. Number 1 says, find the cumulative area that corresponds to a z-score of 1.15. I'm going to go to my table. I'm looking for a z-score of 1.15, so I want to be on the part of the table that has the positive z-scores. And the way you look up information in this table is you look up the first 2 digits of the z-score, 1.1, and find the row that has those digits. And then you look at the last digit, which in this case is a 5, which I'm going to put in orange. Hopefully you can see a color difference there. And you're going to go across the top and find that written as a decimal. Now keep in mind, because of where it is, this is the tenths place, the 5 is in the hundredths place, so that's what you're seeing here, is it's written as 500ths. And what you want to do is read across the row and then down the column, and where those two meet is your cumulative area. So for 1.15, that corresponds to an area of 0.8749. The next z-score we were asked about is negative 0.24. So I've now gone to the part of the table that has the negative z values, and this chart works the same way. You begin by looking up your first two digits on the left-hand side, and in this case I need to scroll down a bit. Here's the row where I find negative 0.2, and then I need to look at my last digit, which is a 4, and it's in the hundredths place, so it's 0.04. The one thing you'll want to notice is that it goes backwards. In the negative chart, the first column is labeled 0.09. In the positive chart, the first column is labeled 0.00. So always make sure you're reading your headings carefully for the chart that you're on. So now I want to find, in this column, where it intersects with this row, which seems to be right here at 0.4052. So this area for this z-score is 0.4052. Now that does mean it's about 40% of the area, because it turns out, since the standard normal distribution has an area of 1, that's the same as saying it's 100% when we're talking about probabilities. So if the area is 0.40, it's really saying the area is about 40.5% of the total area under the figure. But we'll get there in a minute. And then I added on one last example, because there's one tricky situation when working with this table, and that is a situation like this, where, okay, I would begin and say my first two digits are the 2 and the 1, so I'm going to find that row here. And then notice I have a 4, 5. What you really want to think about here is I've got two digits. I've got 45. And technically, again, that's in the hundredths position. So this is the decimal representation of those digits. And 0.045 actually falls in between 0.04 and 0.05 on a number line. So what you're going to have to do in this case is, we have a 0.04 column and we have a 0.05 column. And what we're saying is the one that I need to look up actually falls in the middle of these two. So what you're going to do is you're going to read both of these values down to the 2.1 row. So 0.9838 and 0.9842. And to get the value for 0.045, you're going to add these two up and divide by 2 to find the middle, because really that's where I want to be. So again, to find the area for this one, we actually need to find the value in between 0.9838 and 0.9842. So we're going to add those up. We're going to divide it by 2. And that gives us an area of 0.9840. So that's how you deal with the situation when your z-score, it doesn't just have two decimal places to the nearest hundredth, but actually goes to the thousandth. You're going to want to find what the value in between two columns. So that was a basic introduction as to how to read the standard normal table. Now we can actually get some additional information from the standard normal table. So if you want to find the area to the left of a z-score, that's the area that corresponds to z in the standard normal table. So you just look up the number in the table. So in other words, like this first example, if I want to find the area to the left of z equals negative 0.99, here's my normal curve. Negative 1 is right here, so negative 0.99 would be just barely to the right of that. So this is where my z is located. And when I look this up in the standard normal table, the decimal I get corresponds to this shaded area. The table always shows the area to the left of the z-score. So all I need to do is go look that number up in the table. So for z equals negative 0.99, I go to the standard normal table, I find negative 0.9, and then I find 0.09 across the top, and then I read the intersection point, and I'm right here at 0.1611. So that would be my answer. So this area is equal to 0.1611. All right, now in part B, the area to the right of a score. Again, it's super important that you notice at the top of the table, you have a picture to remind you that z-score is always the shaded area to the left. But if you want the shaded area to the right, that's simple enough to do. The whole area is supposed to total 1. If I subtract off the area to the left of the z-score, that'll leave me with the area to the right. And that's how we're going to do this one. So 1.06 would be located just a little bit to the right of 1. So here's where my z-score is now. And I want the area to the right. So if my z is 1.06, I'm going to go to the table and look that up as normal. I'm going to find 1.0 on the left. Then I'm going to find 0.06 across the top. The intersection of those is the number 0.8554. So that is showing me this area. So the area to the left of z equals 0.8554. So to find the area to the right, you're always going to do 1 minus that number, 0.1446. And that's the area of this blue shaded region. And lastly, you should be able to find the area between two particular z-scores. So z being negative 1.5 is located about here on my chart, and z being 1.25 is located here. And I want to find the area between those two values. So as it says in the table, to find the area between two z-scores, you're always going to use the difference of the areas that correspond to each z in the standard normal table, always subtracting the larger area minus the smaller one. I need to look up what the area is for these two z-scores. And you should be able to do that now. You may want to pause the video, try to do it, and then come back and see if you did it right. And as mentioned previously, you're always now going to subtract those to find the area between them, always taking the larger area, subtracting the smaller area. And that gives us a final answer for this one of 0.8276. Now, it's very important that you can do these things. Again, we're kind of leaving out at this point the story of why we want to be able to do these, but you will get that in the next section. Now let's take a look at what technology can do for you.